So, welcome to another class. At this time around, I'm just to brief you about metallic bonding. Now, when we are talking about metallic bonding, what we are saying is essence is that, okay, metals on their own, they have what we call metallic bonding. Now, the metallic bonding, if you want to explain the structure, is regular arrangement of cations surrounded by series of delocalized electrons. Now, this diagram here explains it a lot. This positive inside circle, those are cations, and these signs that I have there, they are called mobile ions. So they are called mobile electrons. So metallic bonding is regular arrangement of cation surrounded by series of delocalized electrons, and they are held together by strong electrostatic force of attraction. It's the strong electrostatic force of attraction that actually makes metals to have high melting and boiling point. So the series of delocalized electrons, because the electrons are mobile, they call them series of delocalized electrons. The electrons are mobile, they can move freely, and due to that fact, metals conduct electricity. The moment they conduct heat and electricity, the electron from one side can carry the electricity to the other side of that metal, and that is why metal conduct electricity. And another property is malleable. When we mean malleable, it means it can be beaten into shape. Like this, you can shape the metal. That is the word malleable. And ductile means you can cut it into a thin wire. Now, when you apply force, if you look at this diagram, when a force is being applied to this part of this metal, what will happen is that that part will slide over. The part can slide, and when this part slide, they slide without breaking the bonding within them, and that is why it can change shape. So we can mold metals. Why? Because when force is being applied to it, it can change shape. So that's why it is malleable. Then metals have high melting and boiling point. Why? Because they are held together by strong electrostatic force of attraction. So for this part of the something that I've not mentioned is just the metallic bonding. Now, for ionic bonding, they have what we call ionic lattice. Then the ionic lattice is oppositely, and the ionic lattice is opposite arrangement of oppositely charged ions. Regular alternating arrangement of oppositely charged ions. Let me give you an example. Let's use sodium chloride as an example. Sodium chloride has a cubic structure. We are just talking about the structure of ionic. So it has a cubic structure. If you look at this, it's one chlorine and one sodium. So each chlorine atom is going to bond to one sodium atom. So at each point, okay, if this point is sodium chloride, sodium ion, this place will be a chloride ion. This is sodium ion, because so this place will be a chloride ion. So this point will be a sodium ion. This point will be a chloride ion. This point will be a sodium ion. While this point will be a chloride ion. Now, for ionic compound for ionic compound, their structure will have, they have what we call ionic lattice. Ionic lattice is alternating arrangement of oppositely charged ions held together by strong electrostatic force of attraction. So please don't forget that one. This is structure of ionic compound. Now, for covalent compound, they have simple molecular structure in which that structure is just normal arrangement. But what we have what we call macromolecules. So the next class that we have, I'm going to explain what we mean by macromolecule. That is diet structure for covalent compound. But please note what for your metallic compound, they have this arrangement and they have this bonding. And because of this bonding, it is responsible for this property. When ionic compound have what we call ionic lattice, which is alternating arrangement of cation and anion. Thank you.